Hello, everyone, and welcome to the broadcast. I'm newtmechanist, and today we're going to be continuing our game development project. Hopefully, we can get a little shift and get some gameplay related progress in there. We've been a bit in the weeds as far as kind of backbone stuff, which isn't a bad thing so much, but getting some proof of concept on the level flow would be good too, I think. Let's check in with kitties first, though. We do have Sky up in the tree, Ember over there on the table. We have Mason and Sammy on the bed. Sherbet getting a drink. Molly is on my lap. My wrist is being slowly flayed here. Molly is a very groomy cat as far as affection. She will lick you a lot. She is very drooly, though. There's a bit of splash. But she's getting some back scratches right now. Switch on over. And let's do that one. Molly is a little bit fiddlier for how she wants to be pet. She likes back scratches. She has a very, her back hair is very coarse along her spine. Most of her is very soft and fluffy, but that back hair is really coarse and is very prone to generating static, like a lot of static. Got some, just silence a thing here. One moment. Pushing buttons. There we go. There we go. No, Kuro. It's just a nature of the fur. I've encountered a lot of cats where that's where their fur is different. It's a little more rugged, I guess, or coarser there in general. If you brush it out completely, it doesn't really get a lot softer. It does help, but in the same sense that getting the undercoat out of there makes it less grubby. But yeah, you get a lot of variation in the fur of cats, even amongst siblings. I had one cat that was really like silky hair, but one of his siblings, it was downright wiry. Very coarse fur, very bristly. And even then, you get a difference on the fur. Sky is very fluffy, but his back fur is a lot more of a coat. Now, I don't deny that the grooming would probably change that a little bit, but it would probably just be that some of the undercoat is worked out, and you're less likely to get kind of oil buildup. But yeah, you get a good undercoat brush in there, and you can definitely see that the actual fur is different. Yeah, you gotta get both hands really work into the fluff. Oof. Hello, Sherbet. Sherbet is using my headrest as transit. Say hello. Okay, Karu, so what we're going to build today, ideally, is we get the room structure rolling. We've spent a goodly bit of time prior to this getting our data structure kicked over to a more robust, like, dependency injection pattern. And I think I've got all the bits wired up again. So there are a couple of things that we're going to be working on here. Let's just show that the bits are indeed functional. We still have some tweaking to do on how the collision spaces are generated. Some of the things as far as timing of removal. Also graphical. We do still get a little bit of a graphical glitch where the main body of the entity won't show. There's some logic that says if you're too far away, don't animate this. But I'm seeing that there are some hitches in that, so we might have to just revisit it. But that's a later thing. That's a later thing. We've got everything else functional. The weird texture on the ground is the start of rendering a map, but again, we're setting that aside. There are a lot of little, like, subsystems that we'll need to get in place to get the rendering right, to get the collision space right. All kinds of stuff. We have ideas for that, but we get into a complicated area that is probably going to be a lot of staring at the screen and potential head keyboard intersection. But back before we started flipping the table as far as how all of this ends up functioning, we started the process of getting levels in place. It's better than feco-ventilatory intersection, at least. Okay, so what were we left with? Level entity was away. Okay, this was the beginnings of the trigger process, where we would have entities that would essentially say, okay, this other entity can activate now. We'll need to potentially rewrite this whole process here. For maps, we had room render, which we'll get back to. So, as a refresher, our process is largely going to be left to right movement with exits that are triggered as a part of moving through the level, as a result of some actions, or as far as getting to the far right side. Getting to the far right side is always a pathway. So the model is akin to things like brawlers and side-scrollers. So if you've ever played something like Metal Slug, we're going to put that in 2.5D and kind of have a survivor's gameplay, but with a brawler kind of map flow. So we need a object that represents the overall kind of level flow, or at least the level structure, like what kind of tile sets do we use, that kind of thing. We need a structure to represent which room you are currently in, and it needs to track. One moment. Be right back. Be right back. Sorry about that. There's still some lingering health-related things from last week. So coughing and whatnot will be a little more frequent. But to your question, there will be up and down motion, like I said, kind of 2.5D. I want the level structure to be such, or at least the room design to be such, that I can put obstructions in the like. The player won't jump, at least in a traditional sense, let's say. So we're not talking like platformer style. More like, again, Metal Slug as far as navigation, where you'll have moments where it's like, do you want to climb up the cliff, continue right, drop down through the manhole, that kind of thing. But navigation-wise, more akin to something like, maybe Double Dragon or Ninja Turtles, some of the X-Men games. I'm probably giving an indication of my age based on the examples that I am giving. But yeah. Okay. What do we do? So again, a overall level structure that is just an orchestration system. A room structure that... So the reason that we want to have that level structure to orchestrate is if I ever add the ability to backtrack. If you can ever backtrack, then having the level structure to show the kind of the pathway between them, or to keep track of that, will be important. We're not going to do that for now, but if we set up the structure well, it will prevent it from becoming an issue down the road. Like we won't have to rip up all we won't have to rip up the floor and walls in order to rebuild the frames, Then within each room, you would have the layout, the actual floor, the walls, as well as what is present in the room. Okay. So that's where things like the level entities came in, is that you would have this entity is tied to this one. The purpose of the first entity is to send a message to the second one to wake it up. So if I step across this line, this spawner activates. We don't technically need this entity. We could create great big boxes around the spawner ones that say, if you touch this box, I'm going to stop caring about collision and will start spitting out creatures based on my rules. I think we're going to go with that pattern for now because it's easier. There is nothing that would stop us from revisiting this level entity pattern. But if we go with the idea of a spawner is a particular entity, then we can use the basic entity structure as well as the behavior structure. Effectively, we would have a behavior gate in place that is set off by player collision. Once the player has collided with this thing, the gate opens. We disable collision because we don't care about it anymore, and then the rest of the behavior chain can happen, and that's just going to be time passed messages being relayed down the chain. I do need to have a way to indicate that there is nothing that cares about this kind of message, so don't subscribe to it. But for the time being, it's just it's largely going to be time passed messages that it cares about. And that will spawn creatures in the associated fashion. So they don't really need to be special. They just have a particular set of behaviors. Okay. So then... So this is the entity in the behaviors. This is also an opportunity to change the idea of a spawner. Right now, this is kind of how weapons work, but that's largely irrelevant. We effectively have a behavior that is do all of these things. It could be a special behavior that has this logic, but it amounts to an entity that exists having a behavior that is, I spawn these things with this frequency, with these added behaviors on it. It could be freestanding, because any sort of entity could have these. Because if it's a freestanding set of effectively invisible entities, then we don't need special behavior for them. We could still wrap them in the idea of it is a spawner. It spawns entities with this behavior. So how to set them up. So we have our handle message. This whole structure would need to change because it doesn't care about receiving a message directly. And we can make this less cumbersome. This is just a one thing happens. So we could be looking for like game time passed here. Game time passed is a universal tick. That is the physics heartbeat of the whole application is game time. World time is the simulation of the level. World time can be stopped and controlled. Game time doesn't get stopped and controlled. It can be, like mechanically, of course, I can make that happen. But code flow wise, it doesn't. So frames per second would affect game time in that. So physics ticks would technically try to happen regularly, but eventually you can bog the system down enough that physics ticks are happening less frequently than normal. Of course, graphics ticks are going to be affected by actual rendering. Physics ticks happen in a separate process, and that process tries to run them at a fixed rate. But if the system gets busy, that's going to slow down. In our code, we have built it so that the physics tick always happens, as far as the simulation is concerned, at a fixed interval. So everything gets told, this much time has passed. This many fractions of a second have passed. Or this much of a second has passed. Right now, I think it's like everything is like 1/30th of a second or something like that. We have it at 1/30th or 1/60th of a second. So if it's going faster than that, effectively the simulation slows it down. If it's going slower than that, instead of having big lurches in the simulation, it doles them out in smaller slices until it catches up. So effectively, if the game is being slowed down because the CPU is overloaded, the simulation still passes at the same fixed clock rate. As far as you watching it, that means you'll get fewer ticks per unit time, but the simulation doesn't get skewed because we're not getting big chunks of time hitting the simulation all at once. So you won't get that the game is being slowed down so entities are leaping through walls. Instead, it's that the world slows down as your system slows down. That also means that if you're running the game on a potato, that it doesn't really matter. It'll just, the world runs slower. We can give an example of that real quick, because I like to do this. Let's make it stupid. Okay, 3 times per second. It fires a projectile 3 times per second, and each projectile splits into 3, and each of those splits into 3, and splits into 3, and 3, and 3, and then they try to orbit around the player after 3 seconds. They also try to home on entities, which is not cheap. It's going to be hard for them to home on entities because the force of rotate around the player is actually really strong. We are currently, if you look in the lower left corner, there's a teeny tiny number. The top number is visual frames per second, or at least the frames per second that we're getting. The lower number is the number of things in the world. So the number, it's mostly the number of bullets here. But that number of things is actually higher than you would expect because there's a lot of footwork happening. So the amount of work is even bigger than that number. So despite the fact that we're running at 9 frames per second, which by the way is actually pretty good for this, pretty good for over 7,000 things. If you were looking at Vampire Survivors, probably more like 700, let's say 1,500 things would probably be more where you are on the outside. Which means this is way more than we need. We want to be in a position where way more than we need can be run. But even though we're rendering at 10 frames per second, the simulation still runs at its fixed tick rate. So it doesn't matter. The amount of distance that the mouse covers per unit time in the simulation is known. That is absolute. Or at least the amount of time that it has to move is absolute. And it cleans up. Where did I put that? So we can see an accumulated delta here. So we do the game time steps here. We get those prepped. So we say we have game time start, game time pass, or game slice start, game time passes. Then, if we're not paused, we're going to move through our delta here, our accumulated world time delta. And we're going to increment that. If it's at least the fixed tick rate, we consume 1 unit of fixed tick rate. And we pass that value in here. So here's our, where's our world time passed? Oh, well, we're using world time passed here, which is a message with the fixed tick rate. So we get all that loaded up. We have, this is world time starts, world time physics resolution happens. Then world time passes, then the end of the world step, then the end of the game step. And then we update that little number in the lower left. So if I go onto that menu screen, we go into a pause state. World time ceases to pass. Game time continues. So hypothetically, one thing you could use game time for would be a speedrun clock. Such that no matter what you are doing, game time is passing. The time that I would be using to do things like update menus, that kind of stuff, that's still happening. But the world simulation time is not passing when I'm paused. That kind of thing. Okay. A little from column A and a little from column B there, Bigger Ben. You know, graphics rendering is pretty much GPU, so the sprites showing up and them animating, that's of course GPU. A lot of this is happening on the CPU. In the nearest future, I want to get more and more offloaded onto the GPU where I can. But that is a careful balancing act. But I can use stuff like shaders for cleaning up some of the navigation logic, some of the enemy tracking logic. All of that stuff could be things that I touch the GPU for, but I have to make sure that I don't slow the GPU down to CPU time too frequently as far as getting that data. So again, balancing act. I can't recall if there's any other stuff that Godot uses. But again, we want to get as much stuff shared with the GPU so that we can maximize our value here. But assume CPU at the moment. Okay. Spawner, I want to revisit. Level is pretty much where it's at in the world state. Like, this is where we want to be. Implemented that interface. World event list is not really going to be a thing soon. Level entities wouldn't really be a thing because the rooms are going to handle that. Hey there, J-Wing. And I mean, it kind of is. GPU is fantastically powerful, but you simultaneously want to let it do its thing because there's already a lot of optimization for the GPU rendering content, whether it's through shaders that you write for it or similar. So letting it do the graphics thing is already very optimized. So there's leveraging that. You can also do computational work on the GPU. The danger there being getting the data on and off of the GPU. Because every time you do that, there is the moment where you're saying, hey, GPU, hold on a moment, the CPU would like to talk to you. And if you do that too frequently, not only do you lose some of the value of doing that computation there, you also restrain the GPU a little bit. It may not be a lot. It may still give you a performance boost, but you might be kind of dragging down your overall processing power. It is also just a little bit eldritch as far as talking to it because shader language has more in common with C++ than most of the other stuff. And down that language lay madness. It is very easy to blow stuff up, and it is also very rigid as far as how you need to talk to it. Like, one of our problems with our prior compute shader that we were using to try to do collision really efficiently, we were loading it onto the GPU and getting the results that way. But one of the initial problems we ran into is that when you load the data on the GPU, it is very, very picky about how the data is structured. Like, it needs to be blocked out in particular memory chunks. It needs to be loaded in a very exact order. All kinds of stuff like that. And if you get it wrong, then you have a bunch of gibberish on the GPU and garbage in, garbage out. At best, worst case, you end up like stuffing memory in places you shouldn't, and we get into segment fault and other fun territory. But is very powerful if you write the scripts correctly. Super parallel processing. Okay, so it wouldn't be world events because we're going to let the entities in the screen do that. They handle all of that logic. After this long, do these things. As soon as you exist, after the player trips the wire, start doing all of these things. All of that would happen. The map is going to be a visual and tangible construct. This is going to be a lot. This is going to be a lot. As such, we're not touching it. This will be ripping up floorboards, though, dealing with this. So we won't have our world event list. We won't have level map. Instead, we're going to have like a list of entities to spawn and where, like physically in the world where, with the assertion that I know all of the alerts going off at once. You know, app notice, hey, you have a message. Oh, we also sent you a text message. Oh, we also sent you an email. Okay, well, we won't be opening that can. Or at least we'll be letting that can lay on the floor for a little bit. Okay, so it's really just list of entities to spawn and where, and what map to use. And a map is a composite of the floor and the graphics. There was a moment where I had a circular dependency in this because of the way the injection was set up. And that's always good times when you get that nice infinite loop. You know, where one thing needs another, so when you reach for the other one, it initializes it, and then while that one's initializing, it says, well, I need that one that you were initializing a moment ago. So it reaches out to it and says, hey, I need one of these. And the system initializing them says, well, I don't have any that are ready, so let's make a new one. Repeat until out of running memory. Happily, the IDEs tend to intercept before it gets truly out of control. But not always. So the floor is... So what the floor does for us is it allows us to create the collision map as well as the entity flow. So this is walkable surface. So the floor is initially a image. Yep, that's a pretty big deal there, Bigger Ben. Is not only do you have that moment where I have to be able to have the GPU receive the data to set up the execution of the shader when we're dealing with like a compute shader or similar. I'm also talking to it at a slower pace than I can do with the way that like graphics loading and whatnot can happen. As far as like optimization flows and the like. But yes, in general, you don't want to have to give it data any more than you have to. And if you're doing that every physics frame, that's not great. That's partly why I have the physics resolve step, is that at the top of a tick, I have a place where I can say, hey, go check this if necessary. So we would give it a full frame to do its processing, and GPU is stupid fast usually. Again, massively parallel. So a full frame is a long time once we've got it, but we want to minimize the number of times we go and say, go get it. Because as soon as you ask for it, I start a compute shader, I tell it go. As soon as I ask it, give me the result, that is a wait state. That is a, okay, GPU, finish up and give me the results. So that is a, okay, slow yourself down, make this data available to me, transfer it over so I get it, and then go on your way. Yeah, there'll be optimizations inside of it, but that operation is slow, so you don't want to do it a lot. Okay, so we have the floor. We have the walkable surface of the floor, which is essentially empty space in the floor texture. The processed floor texture. Then we also have the wall vectors, which are surfaces that you can't move through, that essentially would shove an entity back away from it as necessary. We can just make the walkable surface also include vectors that say, get away from the wall. Like unit vector level that say, if I am here, I am approaching a wall in this direction. that is not terribly useful. We can make that useful for the player, but it's primarily useful for creature navigation because it would give us a vector overlay for just the raw map flow. Yeah. Yeah. Okay. So, again, flora is an indication of where you can go that isn't a wall or close to a wall, and where there are actual walls. A wall vector is going to give us effectively the surface. Where are the open spaces around this surface? So, lots of footwork in here. Building this is something that we would want to happen in the GPU, because every pixel needs to look at pixels all around it. We want all of those pixels to be handled as quickly as possible. And a multi-part nested for loop on the CPU is not that. Then we have the graphics layer. This is just one big texture. Eventually, I want to be able to break this up into multiple ones for this, so that I can have them like stuck together side to side. But that comes later. For now, a single like half max texture. So something like 2048 or some around that square is plenty to fit into texture memory without risking problems, even on smaller systems. Even with that, we have a lot of space, because here, let's show that in action here. So the game puts the screen is at 1080. So it's already scaling it that way. Then we scale it at 3x. This is a 32 by 32 sprite. There's a lot of space on the left and right of it, but there's only a little space around it, top and bottom. The blobs are about 16 by 16. The base unit of speed I'm currently working with is about 96 per second in speed. Hey, Key. Welcome. So there is plenty of space. Plenty of space on the map, even if we deal with like 2,000 pixels. That is the equivalent of like, let's say like 50 player spaces. That's a lot of space for us to work with here. We can do better than that. We can we can break it down into approximations of the graphics, that kind of stuff, as far as visual versus collision space. But I think if we want to make the rooms bigger and whatnot, it's going to be interconnected images. And individual kind of like pre-processing for each one. Will there be some fiddly elements to that? Yes. But we'll burn those bridges when we come to them. Okay. So that's what an actual... So a room will be... So a room becomes a list of entities to spawn and where, what the floor is, and which graphics to use. Again, this could also be a list of these things with approximate positioning. Fiddlier to get them arbitrarily, but since the graphic sprite or the graphics texture is a one-to-one correlation with the actual floor definition in multiple ways, then it's just a matter of what is the offset for each of these textures that we're placing. For now, this will be where we put the player, like defined as part of the room, because there's only going to be the one room to begin with. Eventually, though, we are going to have to account for the fact that there could be multiple entry points if we are allowing backtracking. But if we are just continuing down a straight line, no matter what choices you make, like if you go through the door, we're going to spawn things relevant to going through the door, but you never go back. You know, once you have made the choice, you can't undo that and go and make a different choice. You just keep going until the level is over. You know, you beat the boss, you're done. Kind of thing. In that scenario, there is only one entry point each time you enter a room. So we'll start there. So we additionally have, eventually, we've got a... I could do that. But that also would connect it to initialized here. We could do... Let's do it this way. Is there a nice... Do we actually have this in this one? Nope. There we go. There we go. Find that. So most of this would be moving to a room and a... So level just becomes a list of rooms. It could be defined like fully with this in here. We just do a full JSON definition. And rooms aren't actually like catalogables. They aren't things that you would enter individually and reuse. But for our purposes, we probably will reuse these rooms. You know, the office room could be something that we reuse repeatedly. You know, sewer tile kind of thing. Could be something that we add over and over. But from a practical perspective, from a maximum flexibility perspective, individually defining them as far, you know, custom crafting each room for a level gives us a little bit more control. Like this room can, this particular graphic, even if we reuse the graphic, could have spawners in different places, exits in different places. Hey there, Crow. Welcome. The name is not familiar, but welcome nonetheless. All right, we're gonna brave opening this beverage. Yay! Well, welcome back. Okay, so we're gonna start with setting this up manually. So our world state gets a level. We set level, we go to the map render and say this is the level. We can probably pull this for now, as we're not actually doing what we need to do. Well, your messages are getting through as well. Huh. When we get a time passed, we just relay it to the level. So world state is currently doing nothing. We don't need world state. We have a level. That's what is happening. Now, could we have it where stuff is in world state? Yes. But now the channel is set up so only that you have to be a subscriber for a period of time before it would let you chat. I may turn that off. I can't turn that off. Will I potentially regret this? Maybe. Oh, no. This one says anyone. I don't know why it would be in sub only. Maybe it's the other one? Checking the buttons. Ah, okay. Boop. That ought to do it, Crow. have to make sure that I have that set up elsewhere as well. And I'll totally remember to do that. Okay, there is value to there being a world state. Because a world state allows us to say, okay, on to the next level. But given the nature of the game, as we want it to be played, I like the idea of a level being a full run. Once you're done with a level, the run is over. And we can just say, okay, this level is this many rooms. And it contains these kind of enemies. Here are your mid bosses. Here's your final boss for the last room. And you're done. So, your Slay the Spire, there is generally a known number of battles that you will go through until battles or events of some kind that you will go through before you reach the end of the map, the top of it. You fight your boss. Perhaps you will end up fighting multiple bosses or that kind of thing, but it is a known commodity when you start your run. Vampire Survivors, you start on the Castlevania level, you're on the Castlevania level. You're there till you're dead or until you're bored of watching the infinite blender run. I kind of like that, and that says world state is irrelevant. It's just about the level. Which means we load the level at some point in the game flow. So let's go here. Right here. So we're starting the game. The game has been added to the tree, which makes it activate. We jump through the hoops. We won't need to do a lot of this soon. We will be, again, ripping up more floorboards to get more and more of this as the map renderer doesn't need to be an instantiated packed scene. It can be an object, which is a node 2D that we will still use in that same fashion, but it is initialized as a scoped object that we would put up here. It contains bits currently that it's important that we make it a packed scene. Or I think it does. But once we have it set up that it doesn't, it ceases to need to be a packed scene, and we just put it up here as a map renderer uses this particular map renderer kind of thing. Same with entity renderer, collision manager, that kind of thing. We get all of those out of here, and prepare game services at most does this, which again we won't need because we can have the instantiation of services get that object, get this startup resource after it's been initialized. I will have to look into where this shows up, because we can just make this a statically loaded thing, and as soon as it's loaded, we get all of this set up. Yeah. Because all of this is just straight up true. And if these don't... if these other things are not part of this process, if we make them services, then this just happens once. So this could be an auto load in the actual program, because these will never change mid-run. These will be things that are known as soon as one of these is instantiated. Ow, what did I... Weird nerve pinch in my hand. You ever get that where it's stuff like, you move your foot a little bit and it feels like the muscles in your foot say, you know what, we need to bend into a U shape right now. And it feels like they're just kind of curving inward, pulling hard. It feels really weird. I kind of had that with my hand where one of the but more of like the nerves felt like, hey, you know what we need to do? We need to go from your thumb to your little finger right now. We're going to go on a trip. Suffice it to say, unpleasant. Anyhow. Services there. You're getting all of that wrangled. Camera is going to be another thing that we need to move in. It should be in a different spot so we can load it properly. Same with adding the child objects. Some of these we won't even need in this fashion. It's a good reminder to do some wrist exercises so the carpal tunnel doesn't start happening again, Headed off at the pass. If I don't remember to do this kind of thing, inevitably I'll play a game that requires my hands to be in just the wrong position for just too long, and then I get, my arm turns into a claw for a while. Have player died here. I have wrist braces, but there's kind of a limit to how effective those will be. They're kind of a slowing factor. They mitigate how long it takes for it to happen, but once it's happening, they tend not to do a lot for me. At that point, it's exercises and avoiding doing the thing until it calms down. I haven't yet reached a point where it's pretty much surgery or bust, but better for me to be physically aware that the issue might be approaching and take heavier action, but in the interim, just do some exercises to avoid it actually happening. Because, full on developing that condition is awful. Just having the minor temporary form of it is excruciating. I try to keep it that way. There's variation, though. It's a big part of it is how the program requires me to hold, to interact with the keyboard and mouse, and how long I can do that safely. Like for me, gamepads are bad for that. Like I can't use a gamepad for very long before it'll start to hurt my wrists. One person that visits the channel frequently, it's the opposite for them. Gamepads are the thing that prevents that buildup. I think I can hear Molly crying, but I can't tell why. What? Yeah, I see you. Let's see if they're visible. No, you can see Sherbet's tail, and he's kind of looking in Molly's direction. No, as I spoke, he actually turned around. James, sometimes they do. For the it's so there's difficulty on that front. So Mason likes to lay on the table, and if you put one of the air hockey pucks in there, he likes to bat it around. Especially if you're there giving him like back scratches and whatnot, he will play with the air hockey pucks. Sometimes when he's playing with them, he knocks them off, but that's not a constant thing. Molly, though, will take the pucks and run away with them. So it's kind of a battle to figure out where they've gotten to. I actually have the goals blocked off. So that the rate of them knocking things into a position where they can't get them is reduced. Okay, have that loaded up. We need the level to continue to exist for this to work. Which means we need a storage variable for it during this. So then down here, instead of this, we'll do this. We pull that out. Okay, so we will instantiate the level. We don't actually care about it any longer as far as the game state is concerned. Okay, so then we go back into level. We are, despite what my social media posts about this might have implied, we are dipping back into esoteric territory, but not too far. It's just a little refactoring. So we'll keep this around. These won't be level entities. They don't need to be level entities. And we don't care about a world event list. So let's break stuff. Now, I intentionally did not tell it rename this because I want to find all of the places where I broke things. So there is no longer a world event list. Gone. these I will rename. Just so. This is the duplication logic for when we pull it from our data store here. And entities. Well, thanks for swinging through, Bigger Ben. I hope you have a good night. We already have an entity. So this is copy. We are duplicating that entity. Oh, we are going to take another quick break. Be right back, folks. Okay. Entity. We're back. All right, so what we're doing is we are jumping through hoops here to clean up the stuff we changed. Hello, Ember. Ember says it's snuggle time. Yeah. Ember needs to get extra attention when she comes up here because Molly likes to sit on my lap now, and that means Molly is too close and Ember doesn't want to deal with that. And Sammy likes to take up my left shoulder, and that means Sammy is way too close and Ember doesn't like to deal with that. Ember is usually very non-confrontational. She's kind of fierce when when they kind of back her into a corner. But otherwise, but in general, she'll back down really quick. Both because she is the smallest cat. She is noticeably smaller than all of them. And because of that, she kind of lets herself get pushed around. Like, Sky is twice her size and likes to bully her. Let's see. Like, when I say Ember would be on my shoulder in Avatar terms, that is, head on shoulder, body cradled fully against torso. But she's itty bitty. So Sky likes to bully her, but if Ember decided to take a swing at him, like when Ember has had enough, she can back him off, because Sky's a big pushover. Similarly, Mason, but Mason tends not to be a bully to the others. Mason's a bully to his brother. Any of them could back Mason off. He's a big doofus. But yeah, for the most part, Ember will back down from any sort of confrontation and just run off. She doesn't want to deal with it. And confrontation in her case means if one of them tries to, like, touch her at all, like they bump into her, she doesn't like that. So, like, she'll go pout if one of them is sitting in her spot. Exceptions to that behavior is she will snuggle up with Sky. And if somebody comes over to, like, lay with her in the spot, she won't immediately run off. If she's comfy and snoozing, she's not going to give up the spot because somebody wants to lay their head on her. Primarily if it's Sky, but Molly has occasionally started doing that. Because Molly has no social grace at all. No physical grace either. This is... There is no longer a trigger relationship. That's something that we never actually did. We don't need entities to add here. We can just do this. Here. Okay, so we have entities. We need a... Set is equal to new list of vector 2s. Then each positions dot add position. So this isn't going to be a for each. This is going to be a for, let's see here. Nope, we are going to... We will let this explode if it goes wrong. So entity is equal to entities I positions I is equal to 0, 0. Okay, so this will fail if entity positions does not have enough positions to cover entities. If it has too many, the excess will be ignored. Okay. This pretty much means we need... This will probably need to be JSON setup. Hey there, Art. Welcome, and thanks for the follow. Kitty is going to sit in her spot. I'm not saying her name because that will lure her over to me. Many of my cats, most of my cats are responsive to their names, especially her. Molly isn't. I'm not shocked. She's not the brightest bulb. Mason, it's largely, I am making noises at him. Sherbet is similar. Sammy is similar. Sky and her, definitely very responsive. But getting there, a big part of it is, using their name, talking directly to them, that kind of thing. They will eventually learn an association of that particular sound with themselves. They don't know their name, but they know that sound means me at them. Okay. So now level has... We don't need a public for that. But now we have a list of entities and places to put them in the structure. Next up, we need to rig this so that it is that we tell it to start. Okay, we are going to have as soon as it exists, we are still going to call its base constructor. Well, we're going to call what the base constructor calls. Attach events, we are going to void okay, so the primary thing that this cares about is going to be actually yes, there is one thing it cares about, and that is when it's ready to initialize itself. And during this process, it shouldn't be possible for it to get one of these messages. So we are going to have a protected Boolean. Two elements here. So public level. Needs to be public. Okay, no, we can't. Deconstructor is special. Detach events. Okay, when we attach events, we are going to get our emits game time. Services.resolve. We will need to rig this up carefully because only the game does this, and there's a particular way to set it up so that the same object is the one that you're getting here. Actually, no, we'll do this differently. World start step. plus minus. We don't care about any of this in this message. We care that we got that message. This will break stuff elsewhere if necessary, but shouldn't here. There. Care about that anymore. Okay. We definitely broke some stuff. Just a moment. And then that and push that and back in. Okay. So this sets it up such that the level is the driver of all of this. So we get it created. As soon as it's created, it attaches and says, on the next world start step, I'm going to get myself all configured. So it attaches to that event. It says, when I get this event, I'm going to load up the entities, and then I'm done with that event. Then when we're loading the entities, we're just going to go through the list, create them, and put them where they go. Configure where they are going to be, add them to the list to be added to the world. This happens exactly once. Now, all of the other stuff also will happen. So where we are getting the level wired in, where logic is going to say, give me the level. That is all going to be a thing. And the level will be something that we need to get. There will be a thing that will contain that. So there will be the concept of a run. So the whole thing that the level is doing. I think we can get away with the level being scoped in some way, but then we need to say which level object. So there's going to be some sort of world state that will allow us to get the active level. How we go about that precisely, not sure. It might just be another interface on the game. All right, so in that light, we are going to go to our services. So when we're looking for a game, oh, no. Okay. We have these emitters set up, so we don't care about getting the game. These emitters are just relays. As in, they don't care where the message comes from. They don't need to get the game object. They just get one of these things that says, anytime somebody needs to raise this message, do it here. And as a developer, it is my responsibility to conscientiously design the code such that these messages aren't being emitted all willy-nilly. I am also a realistic person and realize, oh boy, I'm going to mess that up at some point. But this does make the code cleaner. Anybody that needs to emit this message says, give me the emitter. Like, give me something with this interface services. And that thing do. Whatever it do, however it do. All that the thing that wants this cares is that it can either use it to emit a message and or receive messages. Doesn't matter what it is as long as it do that. As long as it implements this interface, it has the event we want, and you can use it to send that event or receive that event. Hooray. Okay, so we have those. Right now, we don't need anything else from that. We need to rig up the level object. What else did we break? World state doesn't need to talk to the level. We have that set up. This doesn't care about the game time passing. Handle message is still relevant here. We aren't actually doing anything with this object at the moment. This might be the thing that we set up to be, you can ask this for the level. This is where the level is actually loaded up. So that there are other things that this would need to do. At the moment, there's nothing else that it need to do, so we'll figure it out. Okay, we have a completed build, but it's not going to work right because we have changed this structure. So let's go get this. No, not that. Data. Okay. Level test. Okay, we no longer have world event list. Level map we still have. And map texture we still have. We don't care about it, but we got it. Okay, we don't have behaviors in here. We will need behaviors. Oh, no, we won't. No, we won't. That is going to be a part of setting up the spawners. The spawners will need to be fully defined. So that might be part of this, is setting up each of the entities. Hello, Mason. Plans for a soundtrack? No. Hey there, Elman. Exactly what soundtrack we will use? It's not going to be this soundtrack. It's not going to be like the kind of thing I put on stream. If I had to guess, going to be chiptune-y, you know? Not too much, but definitely your 8 to 16-bit era kind of stuff. 8 into, but not late 16-bit, where you're pretty much just getting video game music at that point. Once you get into PlayStation era, it's only as crude as they decided to make it. So world event list has the full spawning logic, but that's not what we need anymore. What we would have is a list of entities and then a list of positions. We can just do that. Okay, so we're going to keep this here for reference. Entities is just a list, so it's not curly braces. So way, ow, buddy, ow, quit it. There, off. If Mason wants attention, he'll cry by the right side of my chair, and if I don't immediately react to him, he will jump up and claw the back of my bicep. That's a remarkably sensitive area. He's not really a lap cat, though. Come here. Come here. There you go. There you go. He kind of sees how Ember gets attention, and he tries to do the same thing, but he's only slightly smaller than Sky, and he's not very bright. So he's going through the motions, but he doesn't really understand what he's doing as far as getting the attention. There's a lot of like him staring into the distance being like, am I doing it right? There you go. There you go. Satisfactory style farming simulator minigame. Not yet, Lunar. As far as like automation games that it's like Star Rupture or something like that has hit early access. I might give that a run, you know. Probably not on stream, but it interests me. You've got a little bit of action tower defense going on. You got some automation. You got some exploration. Seems good. Seems good. Would I ever play it on stream? Maybe. Maybe. Let's see how that goes. It's not what we care about. If anywhere where I have a vector 2 loaded in, I'll have to see. Do not have. That's an anachronism there. So part of making this work is making a behavior that will spawn entities on its own frequency. So we're effectively going to be moving the concept of spawning to an entity, which will make the player weapon array a chain of spawning behaviors. Such that whenever I am rebuilding the weapons, what we do is we create a new entity that we will need to track properly. It doesn't really need to exist anywhere in particular. We just need to make sure that we aren't culling it. whose whole thing is a chain of behaviors that are ones that are created on the fly of the spawning type and are given the entity that is the weapon entity, which we're already creating and stuffing into a spawner anyway. Okay, we'll be getting to that probably next. But for now, I need to make sure that I get the vectors right. They can, Lunar, but they don't have to, is the thing. We could set up like a spawning rhythm. Like, instead of just a second frequency, they could have some sort of rhythm to the behavior. Any number of things. You could even have it set up that there is a wait state between them that will open and close in a particular fashion. But that gets complicated quick. But that is one way to handle the frequency, is to essentially have a gate on them that says, every this often, open once, kind of thing. Hello, Neth. Welcome. And thank you for the follow. So we have entities, and this is a list of things. We need to get this in here, though. I feel like we want that. I feel like we want that. So, okay. Okay, so we have a... And we are going to have to change these. This is going to get fiddly. It's going to get fiddly fast. Because this is a list of entity behaviors. A list of lists of entity behaviors. We could wrap it in another object. To avoid this being too tricky. Because then we're describing an object that would have a list in it. So then we can have a list of those, and those can be defined things. But when we're hard defining something, we still have the world map object for reference. Yeah. Okay, so this kind of thing is a way for it to say, okay, I have a list. When I deserialize this from the JSON file, I'm not taking in a list of texture wrappers. What I'm actually getting is a list of strings. And I'm going to take those strings and extract from the catalog a series of texture wrapper objects. Buddy. Buddy. Mason is crying again. But yeah, Lunar, to get different like spawning rhythms and whatnot, that's likely going to be a gate attached to the behavior that is a gate that has a pass over effect. That is, Even if the gate is closed, the message continues. So how are we going to do this? I want a list of behaviors. I want them to be... I don't want to have a custom type converter for that. That's so fiddly. No? Okay, no. Again, we can work around this by having a custom object that wraps them. Just feels messy. But there's not another good way to do this. So this is going to be an object. We're going to make this a child object for now. Which just has a list of oh, that won't work. Hey there, Glor. Welcome. We could wrap this whole thing with entity, position, behaviors. Yeah, that should still work. That should still work, actually. So we are going to move these in here. So this is going to have entity, set on it, a position, which is a vector 2, then a list of behavior, which is behaviors. That will have these are going to be, so this is gone, which will break stuff. This is gone, which will break stuff. Level entity. So this is a public list of level entity. We have actually come back around to the idea of level entity, but this is no longer going to be a thing. So we're going to get rid of you. Yeah. We will never copy this. No, it needs to. It is a catalogable. It needs to be copied. So this needs a. This needs one of these. Yeah. This is a list of behaviors. Thanks for swinging through, Key. This is the JSON constructor. And that, but it is level entity. So, and services dot resolve should be correct, right? By catalog, yes. So we get the catalog. So entity is equal to catalog dot copy to copy entity. Really should template that. Ember. Oh, okay. Position is equal to copy position for each behavior into copy dot behaviors dot add behavior. Okay, so should we need to duplicate one of these, this is how you do it. for the most part, yeah, that's where we need this here. Or each. It's technically not necessary to do this, but it is the safer thing to do is to create a new copy of everything that we make, so that there's no chance that a reference entity is messed up in one of these processes. Always duplicate them. Okay, so now we have level entities. We know which position these are, so we have level entities. Entities I. No. Catalog. Level entities I dot entity. List of level entities. Yes. Why is it considered an object? That's odd. Odd. Ah. Public. Okay, so we create a copy of the entity. We set its position. Technically, we should do it this way. We copy it. We load up the new behaviors into it. So this, if this entity has intrinsic behaviors, we are adding them in. For the most part, what this means is this becomes the entity's behaviors. But for things like bullets, there are intrinsic behaviors to the bullet. Whereas with enemies, for the most part, their intrinsic behaviors are, I can take a hit, if at all. Just as likely, they would have behaviors that are, empty, and then I specify this version of it has 10 hit points kind of thing. Okay, so now we need to actually specify in the JSON this thing, which we aren't going to say which type it is. We are going to say that it is in the list of level entities, and each of the things that we are loading is going to have these properties. This is level entities. And each of these is an object. Just so. Each of these has entity, position, and behaviors. This is one of the fiddly bits. Should be capital X, capital Y. Down and right a bit. Entity should be a deserialize as well. JSON. So this, we're going to take this same thing here. And this is not a list converter. This is a catalogable name converter. And it wants an entity. Okay. So I'll take this. Have behaviors, which is a list of strings, just so, like that. Okay, so we're going to start with this because we need all of this to come through. There is no world event list anymore. There is a world map, level map, which is specified here. So we don't need to worry about that little bit for now. So we take that, we build here. And we should get to this during the construction process. Does not break there. So this is where we're creating it during the system load. So we want to get to here. And we step over U and we look at level and it is nothing. So level test did not load properly. So we're going to stop that. We're going to go over here and we hop up and we go to logs. We look at today and yeah, that's about right. Trailing comma. Oh. You can turn that off. It is a special configuration, so I'm not doing that right now. Step over. Level is a thing. It has one level entity. That level entity does not have a proper position. Okay, so that didn't get loaded in correctly. Its actual structure. Now we're going to grab our level. New. It has X and Y. Check here. Documentation search. Okay. Is it going to be dumb and require that? Level entity there. Its position is still not loaded. It's also a Godot vector 2. Here in level is a Godot vector 2. Okay, okay. Can we do That straight up explodes. So fiddly. Fails again. Just couldn't convert it. Okay. Fine. That's the way you're gonna be. So we're gonna need an example one. Let's just use you since you're a single thing. Extend this, but for a vector 2. So what we're doing here is we're making a class such that we can specify this is a Godot vector 2. This is how you read and write it. We don't really care about the write portion because we never actually do that in our code, but we're still going to set it up. Actually, we'll throw a not implemented error. I don't actually care about it. It's not enemy health converter that we want. We want this one. So we're going to get you. So what we're saying is this needs to be a string. We're going to say that the string is just 2 numbers split by a comma. So we're going to get our string, reader.getString here. We have a split in C#. Yeah, split on comma. Gives us a string array. Needs to be exactly too long. If it's not that length, then we have a problem. What I may be able to do, or what I may end up doing, is to have multiple of these defined here and have some variations on it. But we'll see. We'll see. Y is equal to that. Vector x comma y. There we go. So then we're going to use this when we're deserializing it. So we'll take this as a template. We do this, and it's actually going to be a vector2 converter. Okay. So once again, you don't need you. It is this. Level entities, entity 1, position 500, 500. Yay! Okay, so there should be one blob. Yeah. One blob. Okay, so one of the things that this is going to mean is that there will be a whole other class of entity that needs to be ignored for the purposes of culling by distance, and is set up such that it will self-destruct once all of its behaviors are done. Mason. Or I'm sorry, ultimately when you leave the room. Because the entity itself won't have any idea about its behaviors. And any individual behavior can't say that it's time for the entity to go away, because there are other behaviors that might still be running. And there's no good way to prefabricate that. We could make it into a handle message, just like we do for the weapon initialize logic, where we send it down the chain and say, okay, do what you need to do to get started. This thing that I'm proposing makes that different. Like, it will make it different because we aren't setting up the weapons in the same way. Because we're creating a chain of behaviors. which is, different than setting up a chain of spawner objects. Okay, we have created the level object, and by default, it's functional. Do we have some behaviors for that? Sure, we have removed any reference to level entity in other objects. That change. That in there. These commits aren't perfect. Sometimes I get them out of order, but it's largely just so that they're there with a comment, such that I can look in the right area and say, where did I mess up? Okay, so now we need to look at our behaviors and determine it's going to be in the entity logic. Yeah. Do I already have something for spawning? So here's a spawner behavior. Which entity with which behaviors at where? And at what frequency? These are catalogable. We don't need to use them as a catalogable. Okay, when we are defining the entity, the behaviors that we're putting in there should be behaviors like this. As in, we aren't creating an actual entity. We are creating entities that spawn other entities. We could still set these up, but that means that there is a maintenance overhead to find which spawner behavior is being used in which level for which entity. Effectively finding all the places that is done, because if I mess with one of them, if I mess with the core, I mess with all of them. And I don't want to create a lot of behavior bloat individually defining these. But I'm still going to end up doing that because you'll have things like a gate. But a gate can be defined because it is a behavior. We can put a gate on it. And that already has a name converter. So we don't have a problem there because spawner behaviors are behaviors such that they can have a gate. So we could make a blob that spawns other blobs with the relevant behaviors. Yes. Okay, so we're going to change the behaviors from being a catalogable name converter to being a list of behaviors. So right here in level entity, this is now different. This can get tricky. Oh, this would be even trickier. There's nothing that says the thing that is spawned has to be a spawner. And if we say it's a behavior... No, that's okay. This is okay. We have to fully specify. The spawner behavior can have arbitrary behaviors in it, but we're using those by list. That's okay. Because those are the ones that will be assigned to the entity. But the ones that we're putting on the level object should not be regular behaviors. This is unique to this particular instance in the level. Okay, so list of behaviors. So we go back into our level. Instead of this, we are going to have a behavior object. Just so. And it's going to have a type parameter here. And that will be spawner behavior. And spawner behavior here is going to have an entity. Mason. No amount of scratching at the plastic mat will bury the loose kibbles. Mason hardcore tries to bury anything that is food-like that is left out. As soon as he finds it, he will start doing that. It is kind of obnoxious because even if it's like a bowl on a table that you have looked away from for a minute or two, he will try to like kick dirt into it. So we have an entity, we have a list of behaviors by name, and we have a spawn point and a frequency. Okay, so we're going to get an entity, which is a string. We're going to get behaviors, which is a list of strings, which is going to be our move to player. Let's make sure we get that. Logs folder, data. Spawner movements. Comma delimited file, flashbang. Move to player. Frequency, and that is 1. So we're adding a single behavior that is a spawner behavior, that is the Nano blob that will move towards the player. That is triggered by a Nano blob spawned here. This thing can be removed and it will stop the spawns. Let's say we're going to start at once per second to see how this do. We're also just going to see if it do at all. is a level. There is something in the level entities. The first one is a thing that spawns an entity that has no behaviors. It spawns that entity. It has these behaviors, which are a spawner behavior, which has this entity. It has no catalog name. That's fine. So it spawns the nano blob. Frequency of 1, has no gate or spawn point. We didn't give it a spawn point, so it won't work. And it has a move straight line that has a target to the player. Okay, we need to get a spawn point in here. Going to look at our data. We look at spawn points. Spawn around player. Again. Get to here. So we have our level that is a thing that has one level entity, which has a blob that is loaded with these behaviors, which is a spawner behavior, which has our blob entity, a frequency of once a second, no gate set. Its behaviors will be set to move to the player, and its spawn point is around the player. This is the only one that's being spawned, though. Okay. Behaviors and a spawn point. Gets its message, it copies the entity, it builds the behaviors, it sets its position, it adds the entity. Okay, our spawner behavior is never firing. So we are gonna... What am I gonna do? Is spawning. Is never spawning, is never checking frequency. It is way more often than it should, but hey. time passed message. We add our time passed delta. Pause there. I'm going to pause here. Okay, so the spawner is gone. Frequency is 0. Okay, so frequency starts at 0 for a spawner behavior. Setting frequency to 1. Hey, Amethestra. Welcome, welcome. We are working on getting our our map set up. We're doing one big map for now, but we're going to transition to multiple little maps shortly. This is gameplay related, but kind of foot in the door on this particular system. Proof of concept. So we have a level, have level entities. Level entity 1 is creating a blob at this position with this spawner behavior. That spawner behavior has a frequency of 1. But it won't. Okay. Nice. That'll be awful today. Sky strafing for attention too. Okay, frequency wasn't being set properly because we're not copying frequency. You gotta copy it. Behavior, spawn point. Copy, copy, copy. Get frequency. Okay, anything else? All right. Okay, we're loaded in. We have our level. We have entities. There's 1. Our behaviors are this spawner behavior. This spawner behavior is a frequency of 1. Okay. We get in here. We have a frequency of 1. All right. So this is the thing that is causing the spawning to happen. Once this is removed, boop, we will not get any further spawning. So very shortly, all these blobs will be cleaned up. Okay, so spawner behavior is going to need to be more robust in how it's set up. So we're going to need to have things like how many are spawned as well. 0. But being helpful and be useful. For each count, we do this. Those, and we say add entity here. And we want to get the catalog to iCatalog. Catalog. Do services dot resolve. iCatalog. Come here. Come here. Rubbing your cheeks on the camera, sir. This guy makes mischief when he wants attention, and he's not getting it exactly when he asks for it. So he is now... something in my eye. Getting all of the attention that he wants. Or more than he wants. Gets back scratches right now. Solve catalog. Whoop. Then we say catalog.copy. So then build it. So we do that for count times. So now we are going to say count. And we could say something like 10 of them. Now, what I can also do is make child versions of spawner behaviors that have variations on it. Or I could make like a type that interprets frequency and count differently. So frequency could be dealt with as a timer before it does it. Actually, we are going to say okay, we're going to do this differently. No. So that's equal to 0. Okay, count times once every frequency, we will emit amount of them. So if it's time passed, detected Boolean bool amount left. Int. Okay, how are we going to do this? Okay, no. It'll start at 0. We're going to start with this. So what this is going to do is say amount left is equal to amount. So if there's count. It's count. Okay, so this creates a circumstance where we're saying this is how often we'll spawn, this is how many will spawn each time. Then, if we have a count greater than 0, that's a number of iterations max. So is spawning will be true here as soon as we get here. Okay. So this is a spawn happened. So then we're going to say if count is greater than 0, count left minus minus. If count left is less than or equal to 0, is spawning is false now. If we're going to say if is spawning and so for the time being, we're going to say exactly once. So after 3 seconds, once, we are going to spawn 10 of them. Don't need you anymore. That felt like a lot more than 10. So we have a count of 1. Oh. There we go. Spawn starts. 8, 9, and seems right. So if we have a count, we... Oh. No, this is okay. Once we are... If we have... This is saying if you're going to spawn, you will spawn at least once. But we should... We'll leave it this way. No matter what, you'll spawn at least once. So This is essentially saying you don't bother setting it to a negative count or a 0 count. This should create a giant ring of them after 3 seconds. And go. Nice. Nice. All right. Okay. So this is the groundwork here. We have everything we need to make a room. So if we make a series of rooms, then the level can load up the first room. We don't have logic for there being other rooms loaded, but for the time being, we could essentially hard code that. And then have some mechanism for load the next room. Then we could also have logic that calls out there is a room change happening. So like player exits room. And that happens before the next room is loaded. That is an opportunity for any spawners to say, or any entities in the field to say, oh, freeze. We would probably also do a clear bullets event kind of thing. So we could have all behaviors subscribe to a room change. We would need a way to reactivate them when the room is done. We don't even need to do anything particular with bullets. It's kind of a waste, but we could have it such that every entity that is loaded during a room is a member of that room. And that room will handle the activate, deactivate when they leave. That way, entities don't need to know about rooms. And as far as they're concerned, as far as the room is concerned, what it's doing is setting them inactive as soon as we switch rooms, so that they no longer do anything. And that room is going to assume that anything created during it being active is part of that room. So we'll need to watch out as far as when the player is created, that they don't become part of a room. They'll need to be created outside of rooms. This will be a bit hacky. kind of a room scope thing. Yeah, we'll have to see how that goes. But yeah. Let me check something here. And that. No, this is a good ending point. This is a good ending point. I do think we've got the momentum to pick up again tomorrow, barring any sort of calamity. And we've had some unexpected events endangering the schedule today, but we're still on track. We're doing okay. We're doing okay. But yeah. So what we accomplished today is we have the skeleton of the level infrastructure. Next thing we're going to do is we're going to break that out into rooms, such that a level contains multiple rooms. Those rooms will have all of the definition that we currently have, the level entities, the map definition, all of that stuff will be part of rooms. And so the level will load the first room. It will contain connections between rooms as well as which room you're currently in. So we'll also need to figure out a way to mark those connections between rooms. Could end up being another collidable entity. Additionally, we need a type of entity that is a spawner. That we need a way to handle no entity visual. We need to make sure that there is a way to handle no entity visual. And that should be that the entity rendering service just ignores it. If an entity is created and it has no visual, then we don't care about it as far as rendering. That paired with the entity type that isn't something that bullets consider an enemy, but can still collide with the player, gives us our spawner. And since those spawners choose how to spawn with their spawn point, which is another thing that we may need to hard encode with a spawn at point kind of thing. But we'll see on that. But largely it is, next up is breaking the level out into room pieces. We'll start by just loading the first room. We will have a collection of rooms, but we load the first room. And we'll see from there. We'll have to see from there. But in any event, folks, I hope you had a good time watching with us today. If you like what you saw, would like to see more, remember to like, follow, subscribe, comment. All those buttons are generally good, and I would appreciate if you press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific means, such as membership, subscriptions, all that good stuff. You get access to emotes, and when I do actually put videos up, early access to those. You can also do off-platform means that are usually more direct methods of funding, but they are not associated with the platform-specific perks. But with all that said, I hope you have a good rest of your day, and I'll see you next time.